So I had 4 graphs for you to do here. Let's go ahead and work them out. So this first one, my slope is 2/5, and my y-intercept is 4. So I'm going to start on the y-axis at 4. And then remember 2/5 is telling me to go up to right 5. So up to right 5. Or I can go to the left 5 also. And down 2. Again, notice it all goes on the same line when I do that. So we connect our dots. I got close anyway. And that's the line that is formed. Number 2, the number 2 has an f of x there instead of y. Remember, the f of x and the y are the same thing. Okay, so we don't need to worry too much about that. Over here, my slope is 1. My y-intercept is 5. So I'm going to cross the y-axis at 5. And then I'm going to go right 1, up 1, or down 1, left 1. And that's the line that is formed. For number 3, my slope is 1/2. My y-intercept is -3. So I start on the y-axis at -3. A slope of 1/2 tells me to go up 1, right 2, or down 1, left 2. They create points on the same line, and that would be it. And then finally, the last one did try to throw you for a bit of a loop here. Notice that I reversed the orders of these. My slope is -1. My y-intercept is 10. So I'm going to go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put a point. Slope of -1 tells me to go down 1, right 1. Down 1, right 1. And that's what I've got. So, if you had any problems with the last graphs, make sure you leave a comment. We can help you out. Otherwise, let's move on and talk about graphing in context. So here we have a context question. The body length, y, in inches, of a walrus calf can be modeled by y equals 5x plus 42, where x equals the calf's age in months. So the first thing that we need to do here is graph the equation. So we've got a slope and a y-intercept here. We can do that. Notice that that y-intercept is fairly large. So we're going to have to think about how we're going to approach something like that. When it is that large, we're going to need to rescale it. Now, we do know that the y is 5, which gives us a pretty nice number to work with. We can go up by 5s or by 10s on the y-axis. So let's go by 10s. So 10, 20, 30, 40, 50, 60. So my y of 42 is going to be about right there. We have to kind of estimate a little bit here. So a slope of 5 then is going to say we need to go to the right 1 and up 5. Well, right 1 and up 5 is about that. Right 1, up 5. Right 1, up 5. So we get a line that looks kind of like this. Next, it's asking us to describe the slope and the y-intercept in this situation. What does it mean in this particular situation? What does this 5 represent and what does this 42 represent? So we got to think about the context of this problem. Remember that the y-axis is the length and the x-axis is age. So what does it mean to have a slope of 5? Well, a slope of 5 means when we go up 1 year in age, we get 5 extra inches long. So the slope means that every year a walrus calf grows about 5 inches. Because every year it's increasing by 5 inches, right? 1 year, 5 inches. 1 year, 5 inches. 1 year, 5 inches. So that's what the slope means. What about the y-intercept? Well, the y-intercept is right here when age is 0. So what does age 0 mean? It means that they were just born. So 42 means that when a calf is born, they are about 42 inches. Now this this equation is a model, right? So it's not like every walrus calf is born 42 inches, but that's kind of the average. That's the model that we're using to estimate it, right? So there we go. That's what the slope and the y-intercept mean. The slope means how much the walrus calf is growing every year. The y-intercept means when age is 0, when they're just born, how long are they? Okay, so let's answer question C. Use the graph to estimate the body length of a calf that is 10 months old. Well, we only went 4 out here. We would need to go out a little bit more. 5, 6, 7, 8, 9, 10. And so it would be, where does this graph cross at about 10 months? So 10, 20, 30, 40, 50, 60, 70, 80, 90, somewhere between 90 and 100 right up here. So I'm just gonna say 90, about 90 inches using the graph. We can confirm that if we want to just plug the number in here. 10 months old would be, we've placed that for X. 10 times 5 is 50 plus 42, 92. So it's about right? We were pretty close in our estimation using the graph. So this is something using slope and intercept, y-intercept in context. Things that grow at a constant rate are fairly common, or at least things that we can model as a constant rate are fairly common. So having that conceptual understanding here is pretty good. Let's do one more question out of context here before we end this video. So this is a graph in standard form. Now notice that standard form is an x, then an x term, a y term, and then equals to 10. The general form of this would be ax plus by equals c. There are 2 ways to graph this, and I'll go ahead and show you both. The first way is to solve for y, then graph. If we can solve for y, we end up with a y equals mx plus b equation. So if I have 5x plus 2y equals 10, we learned in chapter 1 that we subtract 5x from both sides and get 2y equals negative 5x plus 10. Then divide everything by 2. We get y equals negative 5 halves x plus 5, which we can then graph on an xy coordinate. So we have a y-intercept of 5, so we start here. And then my slope is negative 5 over 2. That's telling me to go down 5, right 2. So that would be my line. If you are comfortable solving for y, this is a great way to do this. The other way that you can do it is to find x and y intercepts. And to find x and y intercepts, we're going to make a little bit of a table. I'm going to choose a couple numbers to plug in, particularly the numbers that are going to get me to cross the y-axis and the x-axis. So if I want to know where it crosses the y-axis, what is the x value on the y-axis, right? This is 1, 2, 3, 4. What's the y-axis? It's 0. So I'm going to plug in 0 for x. So that's 5 times 0 plus 2y equals 10. I'm going to divide both sides by 2 and get y equals 5. That should not be a surprise that I have 0, 5, because that's where my y-intercept was on this one. But to find the x-intercept now, I need to do something with the y. Again, on the x-axis, what is the y value? Well, this is 1, 2, 3, so that's 0 again. So I put in 0 for y. Replace my equation. Solve for x. and I get x equals 2. Which should also not be a surprise because there it is right there. There's my x-intercept of 2. So there's my line. Looks a little bit steeper because the points are closer together. But 2 ways to do this. You can solve for y and then graph, or you can find the x and y intercepts. Now, this is something you're going to want to know how to do anyway because we might just ask you to find the intercepts, in which case you're going to have to remember to plug in zeros. So you're going to want to be able to practice that. So I would suggest, as we end this video, as you go back to your notes and check out that that problem I left for you, that you try to graph that one using the XY intercepts method. All right. So we've got one last video in the series after this one, and so we'll see you in just a minute when you've done those problems.